Hopefully everybody has had enough time practicing the first 5 laws, because this video we're going to talk about the very last law and then we're going to put everything together. We've already been kind of putting some stuff together, but so just keep that in mind, and keep in mind you do have a test on this next class, so make sure that you are doing everything you need to do to be successful. So before we go on to the last law, I want to practice one more problem. So I'm going to put a problem up here. 2x cubed y squared z times 6x to the negative 5, y to the 4th, z to the 3rd, all over 18x squared, y to the 9th, z to the 5th. Actually, no, I lied. We're going to do z to the 2nd. I want you to pause this video. I want you all to solve this problem, and then when everybody's good to go, I want you to unpause it so we can go over it together. So the first thing I'm going to do is I need to clean this top piece up here. So 2 and 6 are my coefficients. They make 12. I have x to the negative 2, y to the 6th, and z to the 4th. And this is all over 18x squared, y to the 9th, z squared. So I now see I have a negative exponent. I'm going to move that down. So I have 12y to the 6th, z to the 4th, all over 18x squared, y to the 9th, z squared, x squared. All right. So now what do I do with 12 and 18? I simplify them, and I'm using my calculator to make my life easier. 12 divided by 18, math, enter, enter. I get 2 over 3. Look at my x's. I always go in ABC order, just makes my life easier. I usually always do x first as well, because I like x the best. So, notice my x's. Are they on the same side or opposite side? They're on the same side. So what do I do with the exponents? I add them. Cross out, cross out. Now look at my y's. They're on opposite sides. Where's the bigger y? The bottom. The exponent is 3. Look at my z's. Bigger z is on the top. Exponent is going to be 2. And I'm done. So hopefully everybody has practiced these enough and you're feeling confident, because we're about to move on to law number 6. So let's go ahead and check out what that does. So law number 6. Law number 6 is called powers of powers. Powers of powers. I take an exponent and I raise it to another exponent. So if I have x squared and I raise that to the 3rd power, what this tells me is x squared times x squared times x squared. I take x squared, I multiply it by itself 3 times. So now notice, between all of these x squareds, what operation is in between all of these x squareds? Well, multiplication. So since multiplication is between my x squareds, what do you do with the exponents? You add them. So 2 plus 2 plus 2 makes 6. So I get x to the 6th. Let's look at another one. If I have y to the 4th and I raise it to the 5th power, that means I have y to the 4th times y to the 4th times y to the 4th times y to the 4th. What operation is between all my y's? Multiplication. So what do I do with exponents? I add them up. So 4 plus 4 is 8. 8 plus 4 is... Oh, wait, I only have 4 4s. Sorry, I messed up. Hold on, pause, please. Let's put another times y. Times y to the 4th. 1, 2, 3, 4, 5. There we go. So, all right, now I'm going to add them up. 4 plus 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. So I have y to the 20th power. And if we do one more, w to the 2nd to the 4th power. This says w squared times w squared times w squared times w squared. W squared. What operations between all of these? Multiplication. What do you do with the exponents? You add them. 2 plus 2 plus 2 plus 2 is 8. So alright, my friends, I need a cheat. How do I get from here to there? And how do I get from here to there? And how do I get from here to there? Well, all I do is multiply. I distribute this 3 inside. 3 times 2, 6. 4 times 5, 20. 4 times 2, 8. So my trick, simply distribute outside exponent inside. The number on the outside is getting essentially distributed to the exponent on the inside. I'm taking an exponent that's on the outside, and I'm distributing it inside. And when you distribute, ladies and gentlemen, what operation do you perform? Well, you perform multiplication. So when I distribute 3 inside to 2, I get 6. 5 inside to 4, I get 20. 4 inside to 2, I get 8. So, let's look at an example. X squared y cubed to the 4th power. So notice in this problem, I have 3 different little numbers. I have 3 exponents. I have 2, 3, and 4. Out of 2, 3, and 4, which number am I distributing inside? Well, the only number that's outside is 4. So I'm going to take 4 and I'm going to distribute it to all my little numbers. You can only distribute a little number with a little number. You can never, ever, 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 ever distribute a little number with a big number. So this is going to clean up to x to the 8th power because 4 times 2 is 8, and y to the 12th power because 3 times 4 is 12. And I'm done. Let's try another one. Let's do a to the 6th, b to the 3rd, c to the 4th. This is all raised to the 5th power. So, looking at this problem, just by looking at it, I know I have to distribute. How come? Well, I have a number, an exponent, on the outside of my parentheses. So I'm essentially distributing it to all of my exponents on the inside because I can only distribute a little number with little numbers. So I have a to the 30th power, b to the 15th power, and c to the 20th power. I know I'm done because a, b, and c are shown once, and because I have no negative exponents. Let's look at another one. What if I had x to the 4th, y to the 6th, and z all raised to the 3rd power? How do I know I have to distribute? I have a number on the outside of my parentheses. So I'm going to distribute 3 to 4, 3 to 6. But notice, I have nobody to distribute z to. But I have to distribute it to everybody. So you got to think about it. Well, what's z's exponent since it doesn't have one? Well, it has an exponent of 1. So whenever anybody doesn't have an exponent inside your parentheses, if you want to be really good at this, because this is the most missed law, then you want to make sure you put that 1 there. So I'm going to also distribute that 3 to 1, because little numbers go to little numbers. So I have x to the 12th power, y to the 18th power, and z to the 3rd power, because 3 times 1 is 3. And I'm done. Hopefully everybody's with me, because let's now involve some numbers. So, let's look at this one. 2x to the 4th y cubed squared. No, that's not 2 squared. Let's do cubed. All right, ladies and gentlemen, here's what's going to get you on this problem. Just by looking at this problem, I know I have to distribute. How come? Because I have a number on the outside. So I'm going to distribute 3 to 3, and I'm going to distribute 3 to 4. Now notice, you're going to try to distribute 3 to 2, and you're going to say 2 times 3 is 6. Be very careful. 2 is a coefficient. 2 is not an exponent. You cannot distribute an exponent to a coefficient. When you have a coefficient and an exponent and you have to distribute it, it just gets plopped on the top. Because 2 does have an exponent, it's an invisible 1. So I got to distribute this 3 to 1, but not to 2. So this is going to turn into 2 to the 3rd power, because 1 times 3 is 3, x to the 12th power, and y to the 9th power. And if I write this as my final answer and I circle it and I move to the next question, I'm going to get a point off. Who knows why? 2 cubed, I can clean up a little further and say that just makes 8. So you have to be really careful, and this is the most missed problem, because whenever you see 2 and you see 3 and you have to distribute it, you immediately tell me, oh, 2 times 3 is 6. When in reality, that's not saying 2 times 3, that's saying 2 to the 3rd power. So you have to be really careful. Let's try another one. Let's do 5x to the 2nd, y to the 5th, and z, all raised to the 2nd power. If I can write today, that'd be helpful. Looking at a problem like this, how do I know I have to distribute? Because I have this 2 there. So whenever you have to distribute, I would always preview your problem, and if there's anything in that parenthesis that doesn't have an exponent, you better give it an exponent of 1. So 5 doesn't have an exponent, so I'm going to give it an exponent of 1. And z doesn't have an exponent, I'm going to give it an exponent of 1. I'm telling you right now, if you do this, you're going to be successful. So distribute 2 to all my exponents, because little numbers go to little numbers. So I have 5 to the 2nd power, x to the 4th power, y to the 10th power, and z to the 2nd power. And if I write this, I'm going to lose a point. How come? Because 5 squared I can clean up and make 25. If you go too quick with this, you're going to see 5 and 2, and you're going to immediately make it 10. So you need to be very careful. So what if I had a problem like this? 2x cubed y squared z to the 2nd power times 5x to the 4th y cubed z squared. I got a lot going on in this problem. First thing I notice is that I have this 2 on the outside. So when we were solving equations in the wee beginning of the year, remember we always distributed first? Well, the same thing applies here. Always distribute first. So that 2 that I circled, does that 2 belong to this first parenthesis or the second parenthesis? It belongs to this first parenthesis. So I'm going to take that 2 and I'm going to distribute it to everybody on the inside. But first, I'm going to preview, and if anybody doesn't have an exponent, I'm going to give it an exponent of 1. So everybody has an exponent, so now I can go ahead and distribute. But let me distribute now, red. Distribute, 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 distribute. So I have 2 to the 2nd power, x to the 6th power, y to the 4th power, z to the 2nd power, times 5x to the 4th, y to the 3rd, z squared. So I can go ahead and clean up. Sorry, I'm pushing buttons here that I don't mean to be pushed. I can go ahead and clean up 2 squared and make 4. All right, so now notice, I'm left with this. What operations between everything? Multiplication. So when you have big coefficients, 4 and 5, what do you do with them? You multiply and get 20. And what do you do with exponents? You add them. So x to the 10th, y to the 7th, and z to the 4th. The big thing that you want to take away from this example is you always distribute first. If you can distribute, you better distribute first. If you can't distribute, then don't distribute first. You clean up what you can clean up. So let's look at one more example like that. Let's do 5x cubed y squared squared. Oh no, that's not 2 squared. Times 6x squared y cubed squared. Looking at this problem, how do I know I have to distribute? Well, because I have an exponent on the outside of my parentheses. So that exponent only belongs to this parenthesis. So I'm going to preview and give anybody who doesn't have an exponent of 1. And I'm going to go ahead and distribute him to everybody inside. So 6 squared x to the 4th, y to the 6th. So then I can clean up 6 squared and make that 36. I'm telling you, the more you show work, the less likely you'll screw up somewhere, so just be careful. So now what operations between everything? Multiplication. So I have coefficients. What do I do with them? I multiply them. So 5 times 36 is 180. What do I do with exponents? I add them. So I get x to the 7th, y to the 8th. Hopefully everybody's with me, hanging in there. Let's now talk about what happens if I have a negative exponent. If I have f squared g to the negative 2nd, h to the 4th, and I'm going to raise it all to the negative 2nd exponent. Ladies and gentlemen, this doesn't change. The only thing that this does is I'm just distributing a negative number. How do I know I have to distribute in this problem? Because I have a number outside my parenthesis. Distribute him to everybody inside. This becomes f to the 2 times negative 2 is negative 4. G to the negative 2 times negative 2 is 4. And h, 4 to the negative 2, makes negative 8. If you circle this, you're losing points. Who can tell me why? Because you have negative exponents. Negative exponents turn my problem into a fraction. So circle F, he goes down. Circle H, he goes down. So my final answer is g to the 4th over f to the 4th, h to the 8th. I'm done because I have no negative exponents and because I only see f, g, and h once. I distributed my negative exponent before I moved it because remember that helpful note we wrote just a couple seconds ago? We always distribute first. Here's where it gets really wonky. If I have 2x squared y to the negative 3rd, and I'm going to raise this to the negative 3rd exponent. First thing, I know I have to distribute because I have an exponent on the outside. So I'm going to preview the inside and give anybody an exponent that doesn't have one. And now I got to distribute this. 2 to the negative 3rd, x to the negative 6th, y to the 9th. If you tell me 2 to the negative 3rd power is negative 8, I'm not going to be happy. Negative exponents don't make the problem negative. What do negative exponents do? They make the problem a fraction. So make it a fraction, circle all my negative exponents, bring them down. I have y to the 9th over 2 to the 3rd, x to the 6th. If I circle this, I'm losing a point. How come? Because 2 to the 3rd can be cleaned up to make 8. Try this one. let's do 4a squared b to the negative fourth, all raised to the negative third. Go ahead, pause this video, solve this problem. When you have all solved it, unpause, we'll keep going. So I know I have to distribute because I have a number outside. So I got to give this an exponent of 1 and distribute everybody inside. So I have 4 to the negative third, a to the negative sixth, b to the 12th. All over 1. Bring all my negative exponents down. So my final answer, b to the 12th over 4 cubed, a to the 6th. But I can clean that up a little more. 4 cubed, 64. Hopefully everybody's doing all right. We got one last type of question. What if I have this? What if I have f to the 6th, g to the negative 2nd, all over h to the 3rd, and it's all raised to the negative 2nd exponent. I have a negative 2 on the outside of my parentheses, so that tells me to distribute. So here I just distribute it to everybody. So I distribute it to f, I distribute it to g, and I distribute it to h. So this turns into f to the negative 12, g to the 4, over h to the negative 6. Circle my negative exponents and move them. G to the 4th, h to the 6th, over f to the 12th. I know I'm done because I have no negative exponents and because f, g, and h are all seen once. Let's do one more and then I'll make it super complicated for one last question. 3x to the 2nd over y to the negative 4. And this is all raised to the negative 3rd power. Pause this video, attempt this problem. When you're done, unpause, we'll go over it. So I have a negative exponent. I got to distribute it to all of my exponents. So I put a 1 next to in front of 3. So I have 3 to the negative 3, x to the negative 6, over y to the 12th. So, circle my negative exponents, shift them down. 3 cubed, y 12, x 6. Nobody's on top, give them a 1. 3 cubed, 27, y to the 12th, x to the 6th, and 1. And I'm done. Last question I want to practice. X squared y, which is all squared, times 4x squared times y to the 4th, all over 36x to the 8th y to the 3rd. I want you to pause this video and see if you can figure out how to do this problem on your own, and then we will go over it. Keep in mind, what do you always do first? You always distribute first. So pause this video. When you finish, unpause. So first thing I want to do is distribute. Give that an exponent of 1, an exponent of 1. Distribute, distribute, distribute. I have 2x to the 4th y squared times 4x squared y to the 4th all over 36x to the 8th y cubed. All right, what do I do now? Clean up the top. 2 and 4 are coefficients. They make 8. Whoa, I messed up. That should be 2 squared, x to the 4th, y squared. So 2 squared makes 4. So 4 times 4 those are coefficients. That makes 16. Exponents, I add them. X to the 6th, y to the 6th. All over 36, x to the 8th, y to the 3rd. So now I have 16 and 36. I'm going to use my calculator. 16 divided by 36, math, enter, enter. I get 4 over 9. My x's end up on the bottom. The exponent is 2. My y's, they end up on the top. My exponent is 3. And I'm done.